हेलो हाँ अभी ठीक है हेलो yeah a very good morning to everyone. Welcome to the International Conference on Advances in Science and Science Engineering and Technology 2024, and thank you for joining us today. My name is Dr. Archana Yadav, Assistant Professor, Department of ECE. Today, I have privilege of being your session moderator for this session. Now, I would like to introduce our session chair, Dr. Neeraj Kumar Verma, sir, from Manipal University, Jaipur. So, I want to extend a warm welcome to all our participants joining us both in person and online. So, first participant, and one more thing, all the participants are given 10 minutes only for their presentation. So, if you find if your presentation is exceeding, just jump to the your work and the finding of your work presentation so that you can wrap up within the time. Okay. So, Mr. Lalitesh Chaudhary, you can start now. Mr. Lalitesh Chaudhary, you can unmute yourself and start.
Now? Hello.
Yes, you are audible.
But I am not share my presentation. How can?
Please share your screen. Kindly give me mic.
मैम शेयर करने की परमिशन नहीं है मेरे पास इसको प्रेजेंटेशन को.
ऐसा कैसे लोग make a present. Mr. Lalitesh, now you can try it.
Okay.
Okay, okay. Mr. Lalitesh, I think everything's fine now.
My screen is visible, ma'am?
No, not yet. Just try to share your entire screen.
Okay, enter the screen.
Yes, it is visible now.
Okay. Good morning, sir. My paper ID 11. My name is Lalitesh Chaudhary. I am MPhil student. My topic is an efficient enhancement for robust and reversible watermarking method. content, introduction, proposed model, result and discussion, or conclusion. Introduction. Using the distribute secure mixed histogram technique, this work presents a unique scheme of reversible data heading in encrypted image. A sequence of chosen bit extracted from the encrypted image are compressed by the data header to provide space for a secret data after the content owner has encrypted the original image using the stream chipper. If an image estimated algorithm is used and the recipient simply processed the encryption keys, they can use it to roughly retrieve the original image with good quality. The original image can be properly recovered by distributed source decoding if the recipient processes both the encrypted embedding keys. This strategy works better than the ones that have come before it. Proposed model. Two processes are used in this work: hide and send process and extract process. Hide and send process acquire the secret image due to watermarking, decide who you wish to send the image to, use the pixel selection algorithm to verify each pixel in the original image. A secret image watermarking into 4 equal parts. Advanced encrypted technique was used to encrypt each section. Encryption process. Pick the picture to use as a watermark. Locate the map first. Retrieve the data using a location map. Complete step 1 through 4 again. Decode information. Create a fresh look and feel. Result and discussion. The result that we will obtain if the significant number of the water framework module are executed in a regulated manner. A reliable, secure watermarking technique is provided in the suggested system that prevents the quality of the image after data has been hidden. Data watermarking is completely safe, secure, and 100% reversible under the suggested approach. The user can proceed the watermarking photos here. The user must first select the original image, then the secret image next. The user must choose the recipient of the watermarking image, write a note about the subject, and click the hide and send option. This initiated to process the heading to the secret image inside the original image. Next, the secret image encrypted using the advanced encrypted standard. Then the hidden image is split into 4 equal portions. Following the conversion of the first part pixels value to the equivalent of a binary 8-bit. These 8-bit split into 4 parts of 2-bit each. Next, the original image first max histogram value is changed to the equivalent of a binary 8-bit, and the final 2 bits are substituted with the secret image 2 bits. Conclusion. Watermarking is a interesting subject and outside the mainstream cryptography and system administration that most of us deal with day after day. Watermarking can be used the hidden communication. We have explored the limit of watermarking theory and practices. We planned out the enhancement of this image watermarking system using LSB approach to provide a means of secure communication. This watermarking application software provides for the purpose to how to use any types of image formats to hiding any type of files inside. The master work of this application is in supporting any types of picture without need to convert a bitmap and lower limitations of file size to hide because the using maximum memory space in picture to hide the file. The recent explanation of research is watermarking to prevent intellectual property is evidence that watermarking is not just limited the military and applications. Watermarking like cryptography will play an enhancing role, play an engaging role in the future of secure communication in the digital world. Okay, thank you.
Okay, thank you. Dr. Tarun Kumar sir and Dr. Neeraj Kumar sir, welcome to the conference. Now you can ask the question to the participant.
Hello. Are you audible? Am I audible?
Yes, sir.
Yes, sir.
Okay, Mr. Latesh,
Yes, sir.
what do you mean by the term robustness with your work? How can you correlate this word with your work? Can you hear me?
Sorry, sir.
Can you hear me?
Yes, sir. Yes, sir.
Are you able to understand my question?
No, sir.
You have used in your heading the word robust.
Yes, sir. Yes, sir.
So how can you correlate this word with your work?
Okay.
On what parameters you are having the correlation of this word?
Sorry, sir.
Okay.
Okay.
Hello. Are you audible? Hello. Are you audible?
Yes, sir. You are audible.
Yeah, Lalitesh, one thing I want, like you are using watermark pages, but anything you have done specifically? Are you audible?
Dr. Neeraj, we can't hear you.
Hello. So,
Sir, your voice is quite low. Dr. Tarun sir.
Uh, I am saying that I can't hear Mr. Neeraj.
1 minute.
Sir, your voice is quite low, Dr. Neeraj sir.
Hello. Now it's clear?
Yes, sir. Now it is clear.
Now it's
Yo,
clear. It's clear.
okay, thank you. I want to ask about कि already watermarking in images is being done. So many work is being done. So if you have done any specific work in this area,
Yes, sir. We are using this to approach head and send process and extraction process, sir.
Okay, you are using encryption for images. Then
Yes,
how
sir.
many encryption methods you are compare for getting your research work?
Approx sir 50 to 60.
50 to 60? इतने तो encryption method भी शायद नहीं है.
Okay, encryption method, अच्छा, okay, sir.
Any any study you have made? कि which one encryption method is better for your particular research or the data you have taken?
No, sir, ये तो नहीं study तो नहीं
No,
किया.
no. You need to do it. If you want
Okay.
to create a good research, then
Yes,
you need
yes,
to be
yes, sir.
incorporate all these things. Okay.
Okay, sir. Okay,
Okay.
sir.
That is from my side.
Okay, thanks.
Over to you, madam.
Um, okay, next participant is Miss Avantika. Miss Avantika, please keep in mind that you have only 10 minutes. Try to wrap up within the time, okay? Avantika, Miss Avantika, you can unmute yourself and start the presentation. I think Miss Avantika is not available right now. So we can, Mr. Bhupendra Kumar, you can start your presentation. Mr. Bhupendra Kumar. Mr. Bhupendra Kumar, are you there? Hello, Mr. Bhupendra Kumar or Miss Avantika, please unmute yourself and respond. Okay, these both participants are not available right now. We can switch to offline presentation too. Mr. Zoe Basan Khan. हाँ एक सेकंड. Miss Avantika, are you there? Miss Avantika, are you there?
I answered.
Miss Avantika, can you hear me? No. So we are switching. So we are switching to offline presentation.
हेलो हेलो
Hello,
हाँ हाँ जी मैम.
Miss Avantika.
गुड मॉर्निंग मैम.
Good morning. Now you can start your presentation.
यस मैम. मैम एक्चुअली शेयर नहीं हो पा रही है पीपीटी.
1 second. वो कहाँ चला गया? Miss Avantika, now you can try it. Miss Avantika,
Yes, ma'am.
yeah, try to share your screen now
Okay.
and start your presentation.
Just
Y- Yes, it is visible. Now you can start. Please wrap up in 10 minutes, okay?
okay.
Miss Avantika, please start. Your time is running out.
Okay. Good morning, everyone. I am Navantika Chaudhary from Tirthankar Mahaveer University. And my research topic is text classification using large language model. Authors, it's me and my supervisors, Rakesh Kumar Dwivedi and Mr. Vivek Kumar. This is the table of content, introduction, use models, literature review, research gap, proposed methodology, result and discussion, and conclusion. This is the introduction of my topic. The classification of text is a fundamental task in NLP with application ranging from sentiment analysis to document categorization. In recent time, the introduction of large language model has revolutionized the field of NLP, providing state-of-the-art performance across various tasks. That is NLP. NLP is a field of AI devoted to creating computers that use natural language as input or output. We delve into the architecture and training procedures of LLM, discussing their ability to learn rich contextual representations from vast amount of text data. Furthermore, we investigate various approaches to adopt LLM for text classification, including fine-tuning, feature extraction, and in-assemble methods. These are the used models, first of RNN, LSTM, and transformer. RNN is a recurrent neural network, is a deep learning model that is trained to process and convert a sequence data into a specific sequence data output. Sequential data is data such as words, sentences, or time series data. RNN during language model training, since RNN models can learn to use past input and predict what comes next in a sequence. Next is and the drawback of the RNN is one of the problem with RNN model, that is, as a sentence become longer, the more input that is received and the gap between what's relevant and the model's ability to use it when it's needed widens. When this happens, the model is less likely to successfully predict what come next. Next is LSTM, long short-term memory. LSTM are widely used in NLP tasks that require capturing long-range dependencies such as machine translation and speech recognition. Uh, Second thing about the LSTM, it is a help in task like language translation, where it needs to remember the beginning of a sentence to properly translate and the end. It is also used in speech recognition, where it needs to remember the context of earlier sound, the understand, and the current one. And the drawback of the LSTM is one of the main drawback of LSTM one of the main drawback of LSTM is its limited ability to capture long-range dependencies in sequence. LSTM uses a recurrent structure, which means it processes sequence one element at a time, updating its internal state of each step. Third one is transformer. A transformer is a neural network that collects and processes sequential data like the words in a sentence as it comes in and transformer one sequence into another sequence. This is the literature review. This is the literature review and the findings of these papers and the research gap. Review various literature, conclude that they are various model like RNN, LSTM, and transformer, which are give accurate result. The only need of the hour is to increase the performance. For this, we propose a new performance enhanced tuning model named as PETX, which is based on transformer. This is the research methodology. First of all, we have a text document, and after that, we're doing feature extraction of these text document and apply these three models. First of all, RNN and predict their output. Second is LSTM and predict their output. And last, LLM and predict their output, and comparison in between three models. These are the result and discussion. We have two data sets. One is 10,000 words and second is 2,000 words. And RNN accurate result is 77.34 for 20,000 words, and LSTM 78.77, and LLM is the best result 81.63. Same as accuracy for 10,000 words. RNN accurate result is 80.43, LSTM 81.43, and LLM is 82.86. Conclusion. In this paper, we have presented a review of text classification using large language model. We discussed the architecture and training process of LLMs, and we also explored various approaches for adapting LLMs for text classification tasks. In the past slide, we discussed these results. RN found the 80.43% accuracy with 10,000 words and the 77.3% accuracy with 20,000 words. Same as LSTM found the 81.43 accuracy with 10,000 words and the 78.77% accuracy with 20,000 words. But LLM achieved the highest accuracy, 82.86% with 10,000 words and 81.63% with the 20,000 words. After comparing the models, we can say that LLM give the accurate result as compared to RNN and LSTM with huge data set. Experiments on benchmark data set indicate that LLM based techniques outperform conventional methods. Thank you.
Hello.
Hello.
Yes, Avantika, I have some questions for you.
Yes, sir.
Okay, can you tell me what are the hyperparameter tuning you are using for long language models? Because if you are using LLM, then definitely hyperparameter is a key player. What are the number of hyperparameters you are using?
Uh,
Oh,
सर इसमें हमने जो है जो डेटा सेट का यूज किया था उसी में हमारे 10,000 वर्ड्स और 20,000 वर्ड्स हमने लिए थे इसी में, उसी से
which
हमने इसका
है,
रिजल्ट निकाला है।
so what approach actually you are using for LLM? Like hyperparameter tuning, you need to be required because whenever you are downloading the data from somewhere else, you need to make it correct. Then what is the method you are using to correct your data set? It is pre-trained method, pre-trained data set, or you have to be clear it. Okay, from where you are taking your data set? What are the sources?
सर ऑन कैगल।
On Kaggle. Okay.
Yes,
So what
yes,
is the prominency of this data set? What is the
sorry, sir.
accuracy of this data set? What is the accuracy rate of this data set? Because the data which is available over Kaggle, then either
Yes, sir.
it is a pre-trained, it is clear to all noises and ambiguity. Otherwise, you need to perform this particular things. You have done in your research?
So,
No.
sir, actually, we
Okay.
are working on it. Yes,
No
sir.
issue. No issue. You just note down whenever you are
Yes, sir.
enhancing your research, you just incorporate it. One more
Okay.
question I have. You are saying LSTML is the best, last model is working best. But this model is not matched with your comparative study you have made. If your findings is coming, this particular model is best for your research, then it should be compared with your comparative study also.
Yes, sir.
Okay, you need to be
Yes,
matched
sir.
with them also. Okay,
Yes,
that's
sir.
it from
Yes,
my
sir.
side.
Thank you, sir.
Thank you.
Avantika,
Yeah.
I have one query that what I have observed from your result, that when your bird size is increasing or your sample size is increasing, the efficiency is your efficiency is decreasing. Can you
Yes, sir.
have any? Can you comment on this? Why it is so?
So, when the paragraph increasing, then a little bit जो accuracy है वो कम भी हो रही है. And we are working on two data sets.
No, that is the thing we are I observe. But
Yes, sir.
can you state me the reason?
So, I don't have an reason.
Okay, thank you.
Thank you, sir.
Okay, thank you. Our next participant is presenting their presentation offline.
Hello.
Hello.
Good morning, ma'am.
Y-
Ma'am, this side Bhupendra Kumar.
Yes, yes. Just wait for a minute, okay? After the this offline presentation, you will be the next.
Okay, thank you, ma'am.
Mr. Zoeb Hassan Khan, you can start now.
Morning, everyone. Myself, Zoifsan Khan. I am the assistant professor in the Electronics and Communication Department of Indian University, Lucknow. And right now, I am going to deliver my presentation on the topic. My research topic is the exploration of IHR principle in AI domains within the Indian legal landscape. Now, as we all know that IHR which stands for International Human Rights Law, refers to the laws and principles that protect the basic rights and freedom of all people, regardless of where they live. Artificial intelligence involves computer systems that can perform tasks that usually requires human intelligence, such as understanding language, recognizing images, making decisions, and more. When we talk about intersection of IHRL and AI, we are looking at how the use of AI can impact human rights both positively and negatively. My contents um, my contents are introduction of HRL and AI in India, HRL framework, the right to privacy, freedom of expression, and right to equality, how they are mismanaged in the IHR principle when we are looking at the AI's current scenarios with examples, and then we are discussing the systemic overview of AI ethics and conclusion and references. Now, AI in human rights intersects in various ways, presenting both opportunities and challenges for both human rights as well as in the digital age. Now, in the opportunities, we can say the enhancing access to the information services. Now, when we are talking about enhancing access to information services, AI can democratize access to information and essential services, breaking down barriers caused by language, geography, or physical disabilities. For example, AI-powered translations tools can make information accessible in multiple languages, while AI-driven healthcare diagnosis can reach underserved populations. Now, improving human rights monitoring and advocacy, which is again the opportunity by using the AI, which AI can help identify human rights abuses by analyzing large database sets such as satellite imagery or social media content to detect patterns, misuse, and other things. Now, improving the individuals and communities, AI can empower individuals with tools and platforms to access themselves, mobilize for social cause, and hold authorized accountability. Now, when we talk about enhancing the efficiency and accuracy, AI can improve the efficiency and accuracy of decision-making process in areas like justice, healthcare, and public administration. Now, there are various challenges in the AI against the human rights. The first is the privacy and surveillance. AI technology, especially in surveillance, can infringe on individuals' privacy rights, leading to potential misuse of personal data. For example, facial recognition technology can be used for mass surveillance, tracking individual without their consent or knowledge. Now, the bias and discrimination AI algorithm can perpetuate existing bias present in training data, leading to discriminatory outcomes in areas such as hiring, policing, and services to services. Transparency and accountability is again a biggest challenge in the human rights. When we talk about AI systems often operate as black boxes, making it difficult to understand their decision making process and hold them accountability for errors or biases. Freedom of expression and censorship is also a challenge for the AI system, which used to moderate content on digital platforms, can adonantly suppress legitimate speech, impacting freedom and expression. Now, this is the AI framework, which is considered in the AI domain, where with the various rights as infringed in the civil code also, they are framed in the framework where we see the civil and political rights where right to life and liberty, right to freedom of speech, and right against torture. They all are incriminatory and non-discriminatory, where the right to privacy is against challenge in the AI domain, as discussed. Next one, slide. Right to privacy in the AI system can collect and analyze vast amounts of personal data, potentially infringing on people's privacy. For example, facial recognition technology can track individuals without their consent. Again, the freedom of expression and non-discrimination is again a challenge in the AI domain, where we almost see that in AI algorithms can be sometimes be biased, leading to unfair treatment of certain groups. Their facial recognition can be used in the various social platforms in the advertisements, and sometimes it is a big challenge for the uh, one to manage their facial discrimination on those platforms which are being socially discussed. Next time. Right to non-discrimination. AI systems can perpetrate or exhibit existing biases and discrimination, leading to unfair or discriminatory outcomes in areas such as hiring and criminal justice healthcare. Next. Right to equality. AI technologies have implication for the right to equality and non-discrimination, as sometimes they can be used in the massive hiring where AI systems, irrespective of the individual performance, they just based on the certain merits to take out a decision and which can affect the individuality. Next one. Right to due process and fair trial. AI technologies are increasingly being used in legal and judicial contents, raising concerns about the right due to their process and fair trial. Ensuring the AI-driven decision making is against a very important for decision making platforms. Unlike in the legal aspects, where we have seen various decisions in the past which affected the decision making power of the civil code. For example, in the IT Act 2000 and the Personal Data Protection Bill 2019, which aims to regulate data processing and establish a comprehensive data protection framework, the critics and the effectiveness of these laws in the digital age and the government's commitment to data protection is challenged against and again. there are various cases like in the judicial making where the Supreme Court of India, which has given a judgment in the Putta Swamy judgment as implication for AI governance, which quotes that underscoring the needs of for data protection, consent mechanism, and accountability in AI-driven decision-making process is a big challenge in the AI domain. Next one. Right to work and labor rights. AI technology have implication for employment and labor rights, where we see that automated tasks reshape job markets and impact workers are being affected. Protecting the right to work and labor rights in the age of AI requires measures to mitigate job displacement, promote job creation, and ensure workers' right to fair wages. Next is the right to health and well-being. AI technologies have the potential to improve healthcare by utilizing the day-to-day and the advancement in technology, but they also raises the concerns about data privacy, medical ethics, and equitable access to healthcare services. Now, sharing the data of the personal individuality against for the measures of the advertisement can again leverage to the right, and protecting the rights to health and well-being is again affected. Next. Now we see the ethics for the AI in the IHL principle, where ethical issues of risk of AI generally in the copyrights, in the individual rights, in the freedom of expression, they all are affected by the AI in the social domains. So we need to have some methods to evaluate the ethicality of the AI, and we need to solve these approaches for the problem solution of the rights, human rights against the AI ethics. Next. The collaboration among legislators, policymakers, and stakeholders is essential to improve legal frameworks, foster accountability, and increase transparency in AI governance. We need to have the ethical AI where we need to impose certain laws, and we need also to utilize the IHR principles against these ethical issues to include and promote the right to privacy, right of freedom of speech, right to equality, right to non-discrimination in the era of modern technology. So these differences are. Thank you so much. Is there any questions?
Hello. Hello.
No questions from
Hello.
my side.
Hello.
Yes, sir.
Just I want to know any legal policies are there, or any legal policy will be in future made to AI ethics?
Yes, sir. Right now, in the Information Technology Act 2000, we have certain sections which deals against the infringement and which guarantees the protection of individual rights, as well as we have the Data Protection Bill, protection that is PDP bill, Personal Data Protection Bill 2019, which also emphasizes on these individual human rights and which are being infringed and which are being targeted in the social domain. But we need to regulate this in the current scenario, because almost the cases that are being are reported are very less. Those who are affected, sometimes they keep silent and they are against the
Okay.
workability of these sections are very less.
Okay, that's got it. Okay, thank you.
Okay, thank you, sir. Now, next participant is Mr. Bhupendra Kumar. Mr. Bhupendra Kumar, please
Yes,
unmute
ma'am.
yourself and start the presentation.
Good morning to everyone. Ma'am, am I audible?
Yes, yes.
Okay, ma'am, I'm sharing my screen. Ma'am, my screen is visible?
Yes, it is with no, not right now. 18. Yes, it is visible now.
Yeah, ma'am. Good morning to everyone. My topic is maize disease detection through CNN using leaf image, a review. And my name is Bhupendra Kumar, and my topic, and this is content. Introduction, overview of maize leaf disease and their impact of crop yield, and importance of early detection and classification, literature review, research methodology, conclusion, and reference. Introduction. Currently, nearly 1147.7 million metric of maize is being produced together by over 170 countries from an area of 193.7 million hectare with average productivity of 5.75 trillion hectare, which is not enough to fulfill the global food security as the population is increasing fast. The global consumption pattern of maize is feed 61% and food is 17% and industry is 22%. It has attained a position of industrial crop globally as 83% of its production in the world is used in feed, stretch and biofuel industry. In maize, India is the third most important food crops after rice and wheat. It is cultivated 11.3 million hectare according to 2019 and 22 under a wide range agroeconomical situation. And importance of maize crop, botanical classification. Maize, scientifically known as Zea maize, is a member of grass family. That name is poaceae. Economics importance. Maize cultivation contributes significantly to the economics of many countries. In India, its consumption India in contribute 9% of the total agriculture GDP. And the nutrition value, maize is a rich source of carbohydrate providing energy. It is also contains a dietary fiber, vitamins such as vitamin C and vitamin A, and the minerals including potassium and magnesium. And this is the disease and respective samples. In this research, we are focus only fungal type disease. That name is, first one is a common rust. That is the type of fungal, and the symptoms of the common rust produced rust color to dark brown along with poke on both leaf surface, and that is the image sample. So in the 50. And second one is the blight. It is also a fungal type, and the symptoms are the lesion when race O is present are tan in color with a buff to brown border. And the next one is it is the third one, gray leaf spot, and it is a fungal type, and the symptoms is lesion of gray leaf spot begin as a small dot with a yellow halo. And the next one is it is the literature review. We are focusing some last year researches that a paper title is a corn leaf disease detection and using convolutional neural network. In this research, we finding the accuracy of 93.7% identify three diseases is type of disease is and the method proposed quickly, easy to use, and help low income farmers. And the next one is next literature with image recognition of maize pest and disease based on the convolutional neural network. And in this research, we find the accuracy improved, that is the 97.42%. And the miscalculation या loss is a 2.58% when identifying a disease. And the next one is and the paper title is automatic disease detection and classification in maize crop using CNN. And in this research, the findings is the finding the accuracy of 96%. And these are the some of literature review, and the problem is to build a lightweight and accurate CNN based classification model to detect and classify the disease in maize crop using leaf image. And these are the some tools we are using in this research. First one is a Python imaging tools and OpenCV and Flow. And for background removal, we are using REMDG for Python, and image augmentation, image data generation, and data set split hold. That is the scenario we are split data set 70 to 20 and 10 train test split, and model building implementation Graph and TensorFlow, and graph visualization tool Matplotlib classification report and confusion matrix. And Python programming language is to be used for implementation in the entire world. And this is the research methodology: image acquisition, image preprocessing, and auto feature extraction using CNN, and disease classification using CNN. The next one is a data set. In this research, a benchmark public data set named Plant Village is to be used for disease detection and classification in maize crop. The data set contains 4,354 images of maize leaf infected with three diseases such as blight, common rust, and grey leaf spot, along with the healthy leaf image. And description of data set. These are the description. We are using 1,162 images of healthy and 1,192 images of common rust, and 1,000 images of grey leaf spot, and 1,000 images of blight. The total images of 4,354. These are the conclusion. The implementation of CNN of maize leaf disease detection and classification holds significant implementation for agriculture, offering the enhanced crop yield, reduced reliance and the chemical inputs. And despite the advantage made in this study, there are still area for further. Yeah, these are some reference. Thank you. So have you any question? Hello.
Please wait.
Okay, sir.
Okay.
Dr. Neeraj sir, Arun sir, any questions?
Yes.
Can you suggest any idea for
Yeah,
the
yeah, I have.
practical implementation of this of your work?
Actually, sir, it is in a review paper, so I'm not showing the implementation in this paper.
Okay. So
I'm
this is a
focusing
review
only.
work. Okay.
Yeah,
Okay.
sir.
So you are not aware. Okay.
Hello.
Yes, sir.
Yeah, Mr. Questions. Okay, you have made comparative study about the diseases of the leaves.
Yes, sir.
Am I audible?
Yes, sir. Yes,
But
sir.
your
Audible.
comparative study, your comparative study is missing with your comparative analysis. You are choosing three diseases. Okay.
Yes, sir. I'm using one type of fungal type diseases.
diseases.
That is,
But
yes, three diseases.
but okay. But there are many more diseases are there. You have chosen three, but these three diseases evidence is not appear in your comparative analysis. How you are choosing? What are the parameters through which you identify these are the most critical diseases that may be affected for your particular leaves?
Actually, sir, if
Whenever you are making a comparative study, your analysis will be supported.
sir, these three diseases is a fungal type, and in the literature review, many literature review focus on these three diseases.
No. My question is, in your comparative study, you have made any analysis? I have go through your all 11 slides, but there is nothing where you can show that these are the three diseases mainly used.
So
If you are using anything, any parameter, then you have to be showcased. This is the reason behind this.
okay.
Okay.
Okay, sir.
Okay. So as CNN you are using for the classification of that particular diseases.
Yes, sir.
So you have any other methods used to compare in your comparative study?
Sir, in this study, we are using
Number of methods.
comparative analysis.
With these papers, among them 10 papers, 3 papers shows CNN, 4 papers shows RNN, like this. Among them, you conclude that STM is the best model for that particular leaf classification. If you are making, then you have to analysis also.
Sorry, sir. Comparison.
No issue. I review a for you next papers.
Okay.
Okay, that's it from my side.
Satish sir, please
Hello.
start your presentation.
Yes, sir.
So can I leave?
Satish sir, please start your presentation.
Yes, sir. 1 minute. Sir, I'm not able to share my screen. Kindly allow me to share my screen. Hello. Hello. I'm not able to share my screen. Kindly allow me to share my screen.
Uh, Last participant, please stop sharing from your side. Please make a presentation. Now please try again.
Yes. Is my screen visible right now, sir?
Yes,
Yes, ma'am. I'm
you
very
can
sorry
start
because
now.
I'm joining with my phone, so it's a PDF version. So.
Okay, no issue.
Very good morning to all of you. My name is Satish Chaurasia. The topic of my presentation is multimodal medical image supervised image fusion using CNN with hybrid optimized dynamic. The content of my presentation are first introduction, then literature survey, then multimodal image fusion, then proposed methodology, then result discussions, and then conclusion. So first introduction. So we have a different type of medical imaging systems like MRI, PET, CPET, X-rays, ultrasonography. So we have for a different for our organ we have a multiple kind of imaging system for different patient diagnosis. Now the image fusion, multimodal image fusion tends to fuse all the images into a single image and provide a enriched information regarding the a particular organ by a single image instead of having a multiple images of the different modality. This can be achieved using a neural network as we are aware that the CNN is a type of a neural network which works as a human brain, a part of a human brain which is working images. So the convolutional neural network devoted to work on a uh, 1 minute to for the image processing. Now the third my literature review. So we have shown a multiple literature review here. The first author as Chao Zhang. The summary of his intervention is that he uses MRI and PET images to fuse the images of PET and MRI modality. The technique used by the author was a densely connected neural network, and the results were having a better quality of the fused image into a single one. The second is a Walid Al Safai. The paper uses a deep fusion model where they uses a histogram fuzzy method, and the result obtained by the authors were having a more enriched information from the in a single image instead of having a multiple modality. So now Another here we have shown a multiple literature reviews. Now moving to the problem identification. So that the first challenge is different imaging modalities like MRI, CT, PET. So each modality have its own benefits. Like some MRI are used for the soft tissues, and PET used for the functioning of the organ. So we have a different modality, and imposing all the modalities into a single image may enrich the information into a single image. Now these are the objectives. So the first one, we will have diagnostic accuracy, then reduce the time and effort would be saved while on a different modalities of the image, then improve the treatment planning, as the more enriched information would be provided in a single image, the treatment and planning would be improved. Then the advanced visualization capabilities means the instead of migrating into the different image modality, a single modality of the medical image would be able to provide all the information about the particular organ. Here we have a medical classification of the medical imaging system. The first one is the structural imaging, in which we have MRI, CT, and X-rays, ultrasound. Then we have a functional imaging system, in which we have PET, SPECT, and then the second is the fusion level, how we can achieve a fusion. The fusion can be achieved into the three forms. The first one is a fusion level, the second one is a feature level, and the third one is a decision level. In the feature level, the images are the pixels of the images are directly combined to the pixels of the resultant image. In the feature level, the feature are extracted from the different modalities, and then these features are combined. And in the third decision level, the decision made by the particular modalities are then fused. Here we see the how the image fusion take place. Then we have a particular modality of the image. The second one is the organ from which we are taking the image. Then we have two images, first modality 1 and then second modality 2. Then we have two kind of image fusion. The first one would technique would be a spatial domain, in which directly the image pixels are being fused, and the second is a transform domain, in which the pixels are transformed into some another domain, and then the fusion take place. Then that after fusion we evaluate the process of the fusion based on the some matrices that are similarity matrices, root mean square error, mutual index, peak to noise ratio, and then the fused image, and then resultant is the fused image. Now coming to the methodology, here we have our input image A, then input image B. Both are of the different modalities. Then they are transformed into the non-subselect countlet transform by the we are using a transform domain. And then the low frequency domain images and high frequency domain image are being separated of both the images, and based on the some fusion rule we are fusing. Then we are having a high our proposed hybrid optimized dynamic optimization algorithm. Then as we have transformed the image into the NSCT domain, then we have an inverse transform, then we have the fused image. Now as we see the flow chart, as we see the flow chart, the first we initialize the parameter, then we compute the shardiness of the fitness function, then we have our functional range computation, then we locate the pixel, then we compute the alpha, then we choose the location of the updation, then complete the third line updation, and then optimal selfish is being achieved. Now coming into the results, we have as we see, we have input image CT and MRI. Then we compare the input image, that is CT and MRI images are being fused. So here we have used a multiple algorithm to compare with. The first one is PCNN, NST, then second one is densely neural network, the third one is the DST, and the final one is the ours proposed, that is CNN with the optimized hybrid optimized dynamic. So edge comparing, we have a multiple parameter which we have been using here, evaluation matrices, and we see that our resultant of improved efficiency of our proposed algorithm. Now coming into the conclusion part. So the supervised image fusion using a CNN has made an indescribable. Uh, sorry, sir. Integrating the capabilities of the deep learning with the image optimization method has improved the treatment and planning of our patient care. So, thank you, sir. Any questions?
No questions from my side.
Okay, thank you very much, sir. Sir, may I leave the meeting?
Dr. Neeraj, sir, any questions from your side?
No, ma'am. Thank you. It's a good presentation.
Okay, sir. Okay, thank you. Thank you, Satish. You can leave now.
Okay, thank you very much, ma'am.
Dr. Neeraj, sir, and Dr. Tarun Gupta, sir, thank you so much for your presence and helping us conducting so smooth this session. Thank you, sir. Thank you, all the participants.
Thank you, madam, for giving us the
Okay.
opportunity.
Okay. Thank you,
Shall
sir.
we leave?
Yes, sir. Yes, sir.
Thank you.
Okay. Thank you.